Here's a quick example of a limiting reagent question with percent yield. Here we have two reactants, 25 grams of CH4 and 10 grams of oxygen. It forms 5.2 grams of water. Hence, in this equation, at least, we don't care about CO2. Now we have to determine the limiting reagent. Again, the balance equation is CH4 plus 2 oxygens forms CO2 and 2H2O. So to determine limiting reagent, we figure out what runs out first. So we look at the methane, or the CH4. We have 25.0 grams. We're going to convert that to number of methanes, or the number of moles. 1 mole is 16.04 grams. So if you don't know how I got that 16.04, look it up and look up how to determine molar mass. And then how many CH4s are used per reaction. So really one reaction, the front number in CH4 is 1. Next we have oxygen. Oxygen, you are given 10 grams of oxygen, 10.0 grams. 1 mole is 32.00 grams. And then one reaction uses 2 moles of oxygen. So you're converting from grams to moles to the number used up in a reaction, and you're determining what runs out first. So the lower of the two numbers is going to be the limiting reagent. So for methane or CH4, I got 1.52 reactions. Now I'm looking at sig figs. 3 sig figs there, 3 sig figs there, 3 sig figs here. For oxygen, I'm just dividing all of it, and I end up with 0.156 reactions, because again, if we solve that, 0.156. We got 3 sig figs, 4 sig figs, so the answer should be 3 sig figs, with the least amount of what's being determined. So you have to show all these steps. The limiting reagent is going to be oxygen. So the limiting reagent is oxygen. We can then determine percent yield from that. So the lower of the 2 and the 1 we did before was oxygen. So you don't have to rewrite this. I'll just show you. I'm doing the same thing I did in the last slide. 10 grams of oxygen. 1 mole of oxygen is 32.00 grams. And every molar mass has to have 2 decimal places on it to get full credit. We're looking for product of water, because water is what's given to us. And we know that there's 2 waters, based on the balance equation, formed for every 2 oxygens. So I'm looking at the front number for both of those, hence the coefficient. Then the molar mass of water is 18.02 grams. Here I can then determine theoretical yield. So I'm multiplying across and dividing once, or I'm just entering, or else I'm just entering all of these numbers. And the amount of grams that I get for theoretical yield is 5.63 grams. And I'm going with that because we have 3, 4, and 4. And and I'm going with the least amount of sig figs of the numbers we divide and added, so that's going to be 3 with that 10.0. In the question, I say 5.2 grams of water is formed. So if you form 5.2, and you should have formed 5.63, you can get a percent yield. Divide the 2, and multiply by 100, and I'm getting 9.2%, or I'm sorry, 92%. That's because 5.2 is 2 sig figs, 5.63 is 3. So when you divide numbers, you go with the lowest of the numbers with sig figs. So I do look at sig figs, and there you go.